Hey, so in section 9.4 and 9.5, what we're going to be doing is comparing one or two population averages to our samples. So first note that we will not be learning to do this by hand, but instead we're going to be using StatCrunch. And how to do that is you're going to go stat, tstat, one sample with summary. So let's get started. So suppose we want to know if the average of a population has changed. Okay, so we have three possibilities. First, note that your null hypothesis is always that the mean has remained unchanged. So for example, if we were comparing the average age of death from 1880 to today, we would assume initially that the average age of death hasn't changed. Okay? One hypothesis we could have is that we could say, alternatively, that we think the average age is just different, so just not equal to the old average age of death. The other one is we could think that the average age of death is greater than it used to be, or we could think it is less than it used to be. Now, these have alternative ways of writing them. So a different way of writing this is you can write it instead and say that the difference between the two is not equal to 0. For this one, you could say that mu minus mu naught is greater than 0. And for this one, that's the same thing as saying that mu minus mu naught is less than 0. The reason it's important to know how to write these in the different ways is because depending on what software you're using, it might tell you, or it might be set up so that your alternative hypothesis is formed this way or this way. So let's look at an example. So a light bulb company states that the average life of a light bulb is 2 years. We want to test if the average is different. Okay, so what we do is that we take a sample and find that of 120 light bulbs, the average lifespan was 2.1 years with a standard deviation of 0.31 years. So we're going to set up our null hypothesis. So our null hypothesis is always that the average is exactly what they say it is. So we're going to say that the average is 2. Our alternative hypothesis, well, we just said that we think the average is different, so we thought that maybe the average was higher or lower than what they stated. So we're going to say that mu just does not equal 2. Remember, another way of writing this is saying that mu minus 2 does not equal 0. Okay. Another thing I want to note is that the average life that they stated was 2, and we found that the average life was 2.1. So even though they are different, what we want to test is, are they significantly different? So what we do is that we go to StatCrunch, and we enter this information. Okay. So we entered this information here. And then what we got is that we got this output. So when we're looking at this output, the key thing that we want to take into account is our p-value. Okay? So the rules apply just like they did in the previous chapter, chapter 8. So if we let our significance level equal 0.05, do we reject or fail to reject the null hypothesis? Well, since our alpha value is greater than our p-value, remember, if p is low, we get to reject HO, so we get to reject the null hypothesis. Meaning the evidence shows that mu does not equal 2. Okay, let's look at another example. So a study in the 1960s found that the adult American male had on average 2.3 tattoos. We think that the number has increased significantly since then. A new study found that of 30 males, the average number of tattoos was 4.3 with a standard deviation of 1.2. So our null hypothesis is that mu has remained unchanged since what we found earlier. So we still think that mu equals 2.3. And our alternative hypothesis is that we thought the number had increased. so we think that mu is greater than 2.3. Remember, another way of writing that is that mu minus 2.3 is going to be greater than 0. So we want to put this into StatCrunch, and we're going to let our significance level equal 0.1 and decide if we reject or fail to reject H0. So remember, when you do this, you're going to go stat, t statistics, one sample with summary, and our sample mean was 4.3 with a standard deviation of 1.2. We looked at 30 males, and our null hypothesis is that mu still equals 2.3. And remember, don't forget to change the alternative hypothesis. We think that it's gotten larger. We hit compute, and what we see here is that it says the p-value is less than 0.0001. So let me just go ahead and copy this and plug it into the notes. So here's what that means. This means that our p-value is so close to 0 that the program won't even tell us what it is. So in this case, our p-value is so low that we can reject HO. So since alpha is greater than our p-value, and our p-value is so small, we can reject H0. What that means is we have found evidence that mu is greater than 2.3. That means that we found evidence that men do, on average, have more tattoos now than they did in the 60s. All right, great. Now, the next thing we're going to talk about is what happens when you have two samples. What that means is that instead of comparing one population to a sample, we're comparing two populations using two samples. So this could be if you wanted to compare men to women, adults and children, or any two groups. Okay. So here's the thing, is that our null hypothesis is that the two means are going to be the same. Our alternative hypothesis is that they're just different. So they're not equal to each other, they're just different. And just like before, we can rewrite that as mu1 minus mu2 does not equal 0. Your second alternative hypothesis is that one population is greater than the other, which again you can rewrite as mu1 minus mu2 is greater than 0. Okay? And the third one is that you think mu1 is less than mu2, which we can rewrite as mu1 minus mu2 is less than 0. So for example, if you were comparing, let's say, the average age of death between men and women, you could either have an alternative hypothesis that they're just different, that men have a higher average death rate than women, or that men have a smaller average death rate than women. So let's go ahead and look at an example. So we think that adults between 45 to 65 years of age drink more caffeinated beverages on average than adults between 18 to 45. What we find is the following. So we have information for our first population, mu1. So we have an average for adults between 45 to 65. On average, they have 4.3 caffeinated beverages with a standard deviation of 1.1 and n equals 120. And for adults 18 to 45, we have that their average is 3.8 with a standard deviation of 1.3, and that sample size is 80. Notice that the sample sizes don't have to be equal. That's okay as long as they're both above 25. So our null hypothesis here is that mu1 equals mu2. Our alternative hypothesis, okay, well, let's reread this. We think that adults between 45 to 65 drink more. So we think that the average amount of coffee drank by 45 to 65 is greater than mu2. Good. Now, what we are going to do is we are going to find the following on StatCrunch and interpret the results and determine whether we accept or reject the null hypothesis. We're going to go stat, t statistics, but now we're looking at two samples with a summary. So sample 1, that would be our mu1, and we have 4.3, 1.1, and our sample size was 120. For our second sample, we had 3.8, 1.3, and 80. Okay, now we think that mu1 minus mu2 is equal to 0, and we think mu1 minus mu2 is, well, do we think it's greater than 0 or less than 0? So let's take a look. We said that mu1 was greater than mu2, which is the same thing if we subtract mu2 from both sides, as mu1 minus mu2 is greater than 0. So we want that to be greater than 0, and let's see what we get. So when we hit compute, we're going to get a p-value of 0.0026. So since our p-value, okay, let's say that alpha equals 0.05. Since our p-value is less than that, which is 0.0026, what that means again is that we get to reject H0. What that means is that we found evidence supporting our alternative hypothesis. So we did find evidence that shows that adults between 45 to 65 do on average drink more caffeinated beverages than adults between 18 to 45. All right, let's look at the very last one. So we believe there's a difference in the levels of vitamin D between athletes and non-athletes. What we find is the following information. Okay, so we have their vitamin D levels. Here's what we want to do is we want to find the null and alternative hypothesis. So remember, the null hypothesis is that we think mu1 is equal to mu2. Our alternative hypothesis, well, we just say there's a difference. We don't know if it's higher or lower, so we think that mu1 does not equal mu2. Again, if we subtract mu2 from both sides, that's the same thing as saying mu1 minus mu2 does not equal 0. Alright, we're going to plug this into StatCrunch and we're going to see if we reject or fail to reject our null hypothesis. So one more time, you're going to go stat, t statistics. We're looking at two samples with a summary. Alright, so our sample 1, or mu1, is 45, 3.4, and 38. Sample is 43, 5.8, and 46. Sorry, 5.8. Now, we think that mu1 minus mu2 is going to equal 0, and mu1 minus mu2 is not going to equal 0. That's what we wrote right here. Alright, and we're ready to hit compute. Okay, and we get a p-value of 0.077. So, again, all we're really interested in is what the p-value is. So, let's go ahead and set our alpha value to the standard 0.05. Now, the thing is that our alpha is less than our p-value this time. So our p-value is 0.0777. So since our p-value is greater than our alpha, then what that means is that we fail to reject H0. That means that we did not find sufficient evidence that there is a difference between vitamin D levels in athletes and non-athletes.